Today we are going to learn about implementing security in edge AI systems. We will explore practical strategies to secure AI systems operating at the edge, focusing on protecting sensitive data and ensuring system integrity in distributed environments.
Welcome to our comprehensive guide on implementing security in edge AI systems. In an era where data is more valuable than ever, securing AI systems operating at the edge is critical. Edge AI systems, by nature, handle sensitive data across distributed environments, making them susceptible to various threats. Today, we'll explore the essential security challenges in these environments, learn about data encryption techniques, and discover strategies for implementing secure boot and update mechanisms. We'll also cover managing device authentication and access control, detecting and responding to anomalies, and examine case studies of edge AI security breaches. Furthermore, we'll discuss best practices for securing communication channels and look into future advancements in edge AI security. Let's dive into the world of edge AI security and equip you with the knowledge to protect your systems effectively.
Edge AI environments present unique security challenges due to their distributed nature. Unlike centralized systems, edge AI systems operate across various locations, often in uncontrolled environments, increasing their vulnerability to attacks. Physical access to devices can lead to tampering, unauthorized data access, and device manipulation. Additionally, resource constraints on edge devices, such as limited processing power and memory, can hinder the implementation of robust security measures. Integration with cloud systems further complicates the security landscape, as data must be securely transmitted and stored. Understanding these challenges is crucial for developing effective security strategies that protect sensitive data and maintain system integrity across distributed environments. Data encryption is a fundamental component of securing edge AI systems. Encrypting data at rest and in transit ensures that even if data is intercepted or accessed without authorization, it remains unreadable. Symmetric encryption, which uses the same key for encryption and decryption, is efficient for resource-constrained environments. Asymmetric encryption, utilizing a pair of public and private keys, offers additional security but requires more computational resources. Effective key management strategies, such as regular key rotation and secure storage, are vital to prevent unauthorized access to encryption keys. Implementing these encryption techniques is essential to protect sensitive data and maintain privacy in edge AI deployments.
Secure boot and update mechanisms are critical to maintaining the integrity of edge AI systems. Secure boot ensures that the system boots only with verified software, preventing unauthorized code execution. This is achieved through firmware integrity checks that validate the software against trusted sources. Secure update protocols are essential to ensure that only authorized updates are applied to the system, protecting against malicious code insertion. Implementing these mechanisms mitigates the risk of unauthorized updates that could compromise system functionality and security. By ensuring system resilience, secure boot and update processes protect edge AI systems from a range of potential threats.
Device authentication and access control are fundamental aspects of edge AI security. Authentication verifies the identity of devices accessing the system, ensuring that only authorized entities can interact with the network. Methods such as digital certificates and biometric authentication enhance security by providing strong identity verification. Access control further protects the system by defining permissions and restrictions for different users and devices. Implementing multi-factor authentication adds an additional layer of security by requiring multiple forms of verification. Best practices for managing credentials, such as regular password updates and secure storage, are crucial to prevent unauthorized access and protect sensitive data. Anomaly detection is essential for identifying potential security breaches in edge AI systems. By monitoring system behavior, anomalies such as unusual data patterns or unauthorized access attempts can be detected early. Techniques such as machine learning and statistical analysis enable the identification of anomalies in real time. Automated response strategies, such as isolating affected systems or alerting administrators, help mitigate the impact of detected anomalies. AI plays a significant role in anomaly detection by continuously learning and adapting to new threats. Continuous monitoring and adaptation ensure that security measures remain effective in the face of evolving threats, protecting edge AI systems from potential attacks. Examining case studies of edge AI security breaches provides valuable insights into vulnerabilities and the impact of attacks. Real-world examples highlight how attackers exploit weaknesses in edge AI systems, leading to data theft, service disruption, and financial loss. Analyzing these breaches reveals common vulnerabilities, such as weak authentication methods or insufficient encryption. Lessons learned from these incidents emphasize the importance of implementing robust security measures and continuously updating systems to address emerging threats. Understanding the impact on organizations and users underscores the need for proactive security strategies to prevent future breaches and protect sensitive data in edge AI environments. Securing communication channels is vital for protecting data transmitted between edge AI devices and other systems. Encryption protocols, such as TLS or DTLS, Ensure that data remains confidential and protected from interception. Virtual private networks, VPNs, and secure tunnels add extra layers of security by encrypting data traffic and masking IP addresses. Ensuring end-to-end encryption is crucial for maintaining data integrity and preventing unauthorized access. Implementing these measures helps prevent man-in-the-middle attacks, where attackers intercept and alter communication between devices. By securing communication channels, organizations can protect sensitive data and maintain trust in their edge AI systems.
The future of edge AI security is shaped by emerging technologies that offer new opportunities for enhancing protection. AI continues to play a critical role in developing adaptive security measures that respond to evolving threats. Quantum encryption, leveraging the principles of quantum mechanics, promises unprecedented levels of data security by making encryption keys nearly impossible to hack. Integration with blockchain technology offers secure, decentralized methods for managing data and transactions, reducing the risk of tampering. Despite these advancements, ongoing challenges such as resource constraints and evolving threat landscapes require continuous research and innovation. As technology evolves, so too will the strategies to secure edge AI systems, ensuring they remain resilient against future threats.
As we conclude our exploration of securing edge AI systems, it's clear that robust security measures are essential for protecting sensitive data and maintaining system integrity. By understanding security challenges, implementing encryption techniques, and managing authentication and access control, we can create resilient edge AI systems. Continuous improvement and adaptation to new threats are vital to staying ahead in the ever-evolving security landscape. Collaboration among industry experts, researchers, and organizations will play a significant role in advancing security technologies. We encourage you to apply the strategies learned today and remain vigilant as we look forward to future advancements in edge AI security.